Hello, I'm Nejat Duzgunes. This is Dr. Katalin Karikó, one of the recipients of the 2023 Nobel Prize in Medicine. This was her environment in the 1980s. She had obtained her doctorate at the University of Szeged in Hungary and continued to do research there until funds ran out in 1985. So she and her family moved to the United States, and she worked at several universities. While at the University of Pennsylvania, her efforts to obtain grant funding were fruitless. However, a chance meeting with Professor Drew Weissman at the University of Pennsylvania led to a long collaboration, which then resulted in the discovery that the messenger RNA molecule could be modified to be used as a vaccine. This eventually led to the development of the first effective vaccine against COVID-19. This pioneering work on messenger RNA as a potential vaccine was initially rejected by some of the leading journals in the field, which in essence was a group of scientists who read the paper but did not want it published. Another example of the failure of the process of peer review. Nevertheless, the 2023 Nobel Prize in Medicine was awarded to Karikó and Weissman. Uridine is one of the molecular components of messenger RNA. Natural messenger RNA is normally found inside cells, but when given to experimental animals, it causes inflammation. It is also degraded by natural enzymes. Karikó and Weissman modified the messenger RNA by using pseudouridine, an analog of the natural compound, and found that the synthetic messenger RNA does not cause inflammation. Once it enters cells, this messenger RNA can still make the corresponding protein that it normally codes for.
How does an mRNA vaccine work? mRNA vaccines can be manufactured faster and more cost-effectively than conventional protein-based vaccines. But how do they work? To develop a coronavirus vaccine, researchers selected an mRNA that encodes the coronavirus spike protein. This protein helps the virus enter a human cell. First, the mRNA is prepared by in vitro transcription or chemical synthesis. Next, the mRNA is encapsulated with lipid nanoparticles. This layer protects the mRNA and raises a stronger immune response. The final vaccine formulation is injected into the skin or muscle. Once the mRNA enters the cell, it uses the cell's translation machinery to produce the viral spike protein. The spike protein triggers the body's immune response to produce antibodies and specialized T cells. During future exposure to the coronavirus, these antibodies and T cells will attack the virus, preventing the development of COVID-19.
These are Dr. Uğur Şahin and Dr. Özlem Türeci, a husband and wife team in Mainz, Germany. They are the scientists who first developed the mRNA-based vaccine against COVID-19 in 2020 at their company BioNTech. Their vaccine is being distributed worldwide in collaboration with the American company Pfizer. It is refreshing to see scientists of all ethnicities work on these urgent scientific issues in harmony. This is science at work in the service of humanity. Do these mRNA COVID vaccines have long-term side effects? It is possible, but the benefits of these vaccines have already been proven. Millions of people have been protected from the deadly effects of the coronavirus. More than 1 million people in the US and about 7 million in the world have died from COVID, the vast majority, unfortunately, unvaccinated. When Dr. Karikó was working on pseudouridine in 2005, did she imagine an effective vaccine against deadly diseases, including cancer? Yes, indeed she did. Let us know what you think. We will see you next time.